All right, so we have y equals a sine bx minus c plus d. That's our equation. We're going to go through the different things with that. Remembering that if you missed the test, it is Tuesday at lunch next week, and it's going to be on the topics that we have. So on graphing, which is what I did now, and then I posted a podcast review of Chapter 6. So if you want to watch it on your own or go through, there's a worksheet that goes with it that you can do first, and then watch the podcast. You can do it that way.
Is this a trig test?
Yes.
Yeah.
Well, it is. So, Matthew and tissue sound very similar. Okay, so A, does anyone remember what the A gives us? Yes.
Stretch.
So many good answers actually came out of mouths. Win.
Stretch.
Which was, yeah. Stretch. What kind of stretch? Stretch.
Yeah, I would say a vertical.
I would say a vertical. Okay, so this is your vertical stretch. It's hard to focus with you, so I guess we'll both just have to deal with the two hard to focus things. Now, what does the A do? What else does it give me? Someone else said the right word. Yeah. Does it gives you a reflection if it's
Negative.
a negative. If A is less than 0, you have a reflection in the. Try again.
Yeah.
Oh, try again, Lepp. X-axis, yes, exactly correct. I don't know what I'm talking about. What else does it give you? Someone else said the word. Amplitude.
Yeah, amplitude.
The amplitude is the absolute value of A. The day gets better and better.
I had to call my boss and like explain, and he didn't understand.
All right, so amplitude A. Amplitude is half the distance from the min to the max. Shh. So amplitude is half, quiet, the distance from the min to the max. Quiet, please. Yep. Because there's a trig. Anyone who missed the trig test has to write it on Tuesday next week.
You should do it not at lunch.
Now B, remember we have to go B, X minus, and then it would technically be C divided by B, because we still have to take that B out no matter what. That B gets me a what stretch? Horizontal, and what do we have to remember to do? Take it out, and the horizontal stretch becomes 1 over B. Always flips, right? Doesn't matter what unit we're in, the horizontal stretch always flips. The B also helps me get the period. The period of the graph is 2 pi divided by B. Or if it's in degrees, it'd be 360 divided by B. Or what we can do is we can go 2 pi times the horizontal stretch, or 360 times the horizontal stretch, right? Because we would be multiplying by the horizontal stretch.
That's Dr. Pot.
No. And then C gets me this one's called different things. It's not horizontal translation, it's a horizontal phase shift.
Is that another reflection too?
C right. C over B right.
This should be either reflection.
Yeah, B, if B is less than 0, there's a reflection in the y-axis. And then D is a vertical displacement. Remember it has that weird word? D up in this case. Now remember, I can ask you for a max and a min off of an equation or a max and a min off a graph. A max and a min off of a graph, you could literally just type it into your calculator and look. What does D also give me? Do you remember? Midline. So it's the middle line that cuts the graph in half. Midline, yeah, is y equals D. The midline is y equals D. Remember, it has to be y equals because it's a midline.
Like C over B.
Yeah, because you have to take the B out, Easton. You have to take the B out? COP? Yep.
Okay.
So you get midline equals y equals d. And then remember off of an equation, how do you get the maximum?
Calculator.
No, off an equation, how do you get the maximum? Because sometimes I have variables and not actual numbers in it. Yeah, you take your d, your midline, plus your amplitude. So it's going to be d plus absolute value of a, or we could say d plus amplitude. Yeah?
Scroll up, please. A little bit further. There you go.
Write it quickly so I can scroll back down.
Yeah, I got a few things to write. So give me a second. You're going too quick for my pace and stuff.
Well, I'll be okay.
Okay, I'm good.
Okay.
Oh.
I think you won that one. Okay. So maximum is d plus amplitude, or d plus the absolute value of a. And what's the minimum?
Minus.
D minus the absolute value of a, or d minus the amplitude. Remember that your final is on the 16th, I believe.
Is it open book?
17th?
Yes, open book.
It is not open book. Your final can go in for 20% of your mark, right?
Can replace the test.
But it can also replace the test if it's better.
Can I do both?
Yeah.
Yeah, technically.
Okay, that'll be a game day
So-
decision.
All right.
I just need a 50.
For now.
That would have been last.
That would have been last semester. So range. How do I get the range of a graph? Yeah. So y such that the minimum is less than or equal to y is less than or equal to the maximum. YER in set notation. In interval notation, it would just be square bracket minimum, comma maximum, square bracket.
Lepp, what time is it at the final?
9 o'clock.
Well, that's not fair for people to spare in person are used to getting up at 10
Well-
every day because that causes disadvantages. So I think I should be allowed to come in later.
I think you should just shush.
We don't have
All
school
right.
Friday. I selected. Saw that.
You guys have the retreat, yeah.
Yeah,
Yeah, I saw
Okay,
that.
what's your
I'm not
domain
watching
for trig?
do we have to show up on Friday?
Yes. Well, online.
So we don't have to come to school?
I don't really know what to do with it.
I
Aren't
think
you like the teacher?
it's just an online Zoom call.
It's just a Zoom call, so I would say so that you have access to it if you have.
I'm gonna leak the Zoom code.
I would. Okay. The domain, I would say you're doing it from home, or else everyone would need some sort of device here, and that just sounds scary,
You know
doesn't it?
what actually doing in it? Is it like
I just went over what you normally do, but that was painful.
Yeah,
No,
I
we
wasn't
did not.
here.
We
We
get
can
a
talk
fill out
over
Google
what we
Forms.
do in that grad retreat.
Yeah, what's at the grad retreat?
Nope, I'm not doing it.
Wait, did I actually do anything fun at the grad retreat? Because the way you break it down, it's just like.
Yeah, we used to watch
Forms all
stuff.
day.
I don't know what this one's going to be, because it's going to be different. It can't be the same as before. Like, you used to sign a rock as well with your name on it, and your rocks went to the fountain,
Mountain.
and they sat there for the whole next year when, like, the next year's grads.
Then what do they do? Just throw them in the garbage?
No, they put them out by these benches out here. You'll
Oh.
see all the names on rocks.
Terrible.
Okay,
It's kind of boring.
so an example, you use a paint pen. Y equals -2 sine 1/2 x minus 6 plus 1. So that's going to be our equation. Okay? What's the very first thing we're going to have to do with an equation like this? Take out the 1/2. When you take out a 1/2, it's actually like multiplying by 2. I don't know why that just shifted, but. So we're going to have y equals -2 sine 1/2 x minus 12. Because when you go 6 divided by 1/2, it's the same as 6 times 2. And then plus 1. So what if I ask you for transformations? Nope.
1 second.
It flips when you bring it up. So what are our stretches? A vertical
Vertical stretch. So,
stretch by
up the x-axis.
up to about the x-axis.
We're gonna have a horizontal stretch by factor of 1/2. Thanks.
Oh my gosh. horizontal stretch by a factor of 2 about the y-axis. And we do our reflections. The reflection is in the front, so it's with the y, so it's about the x-axis. So it's a reflection in the x-axis. And there isn't one in the y because the half isn't negative. My translations, I have a horizontal phase shift. Right. And a vertical displacement one up.
What units do we have left?
After other functions, which is the next one, which is 3 lessons, we have terms and commas and binom.
What is terms and commas there?
It's words of fun.
That was my best unit last semester.
What's up?
Did you mark the trig test yet?
We didn't do
Yeah,
it
they're
yet.
in there. It's in PowerSchool.
I don't see it.
Power school or phone school?
Yeah, we
It's being problematic. I know. Yeah, I had to sign out and then put it in, or you can completely delete it, reload it. That way.
24.
Okay, so what if I ask you, Easton, please stop talking. What if I ask you for the amplitude? The amplitude is 2 because it's always the absolute value of A, so that's our amplitude. What if I ask you for the period of the graph? In radians. The period, normally a sine and cosine graph repeat themselves every 2 pi, or 360, correct?
Correct.
The only thing that can change that is if I stretch it out or squish it in. Stretching out, squishing in is a horizontal stretch, correct?
Yeah.
Now this one is a horizontal stretch by a factor of 2. So instead of the period being 2 pi, it's actually going to be 2 pi times 2. You just multiply it by its horizontal stretch and you get 4 pi. This one's going to get wider. What is the midline at? Y equals 1. So is your D value. Y equals 1.
Could you explain to me? I don't get covering the 1/2 out. It's 1/2.
It's just a GCF. It's like if I had 2x plus 3 or plus 6, let's say, and I took a 2 out, you're just GCFing. You're taking a 2 out of here. So you write the 2, and then you get x plus 3. So when you put it back in, like undoing it, you get 2x plus 6, right?
Okay, so why is that one not flipped?
Because if you take the half out, if you flip this to a 2 and you bring it back in, I'm going to get 2x.
Okay.
So you don't flip it because you're taking a GCF of a half out. So the half's out here. And if you want to check it, you can always distribute back in, and you should get what you had before. So if I go a half times x, I get a half x. A half times negative 12, I get negative 6. If you flip this to a 2, you'd get 2x minus 24, which is not at all nice. So you only flip it when you take it out of the equation and put it into words. All right. The range. So I want to do my max and mins. If I ask you for range, you're going to do max and mins first. My maximum is D plus my amplitude, and my minimum is D minus my amplitude. You cannot put these out of order. So what I get sometimes is amplitude plus D, which will work. Then amplitude minus D will not. Yeah.
So is the trig test at this upcoming lunch going to be open book?
No, it wasn't open book for the other half of the class. Why would I make it for you?
Because it's unfair that we have to come in at lunch.
No. All right. So my D is my midline. My midline is at 1, plus my amplitude, which right here is 2. So I get 3. And then my D is my midline, which is 1, and I'm going to subtract my amplitude, which is negative 2, which is negative 1. And the reason why this works, just to remind you, is if I have a midline, a middle line here, and it is at y equals 1, right? That's the middle of the graph. If I add to it my amplitude and subtract from my amplitude, I'll get the highest and lowest I'll go. So my amplitude is 2. So if I'm at y equals 1 and I add 2 to it, I'm going to get to be at y equals 3, correct? And if I'm at y equals 1 and I subtract 2 from it, I'm going to go 1 down to 0 down to negative 1. So that's why it's midline plus amplitude, midline minus amplitude. Okay? What if I give you this? Oh, I got to do range, sorry. Well, domain's just XCR. The range is going to be my minimum, so y such that negative 1 is less than or equal to y is less than or equal to 3. These are always in the same direction, min to max, y year. And the reason why they're in the same direction is because you read from the y. So this is y is greater than or equal to, because it's open to it, negative 1, and then y is less than or equal to 3. So the reason why they're in the same direction is because you read from the variable. And in interval notation, that would just be square bracket negative 1, 3. So now, if I give you y equals negative 2 bx minus c plus a, I want the period, amplitude, midline, max, min, range. So, no, not anymore. It's just the diploma part. But if you're not writing the diploma, the physics 30s earlier. I don't even have to look on the thing. I don't have it memorized. Okay, so this one here is B. Guys, please stop talking. C divided by B. So the period, I take 2 pi and I multiply it by the horizontal stretch. And the horizontal stretch is actually 1 over B because it flips. So my period is 2 pi over B. The amplitude is the absolute value of A, so it's the absolute value of negative 2, which is 2. The midline is always y equals D, so in this case it's y equals K. The maximum, I do D, which is K, plus the amplitude, which is 2. And then that's as good as that one gets. And the minimum is K minus the amplitude, which is 2. And so the range is going to be y such that K minus 2 is less than or equal to y is less than or equal to K plus 2 y year. Or an interval K minus 2 comma K plus 2. Okay, can you open up your notes, please? So we're going to review the vertical and horizontal parts just to bring, to draw attention to that. And then we're going to talk about the points of discontinuity. So on the test, if you haven't written it yet, it has radicals and vertical and horizontal asymptotes on it, if you didn't write it on the Friday. If you did, yay, you can kind of take it and do what you will. Now, what?
Smiles.
All right.
No, it wasn't going to be a stupid question.
Okay.
Easton just made me laugh. Is it, if I do that podcast review again that you posted the night before, is that all that's on it?
Mm-hmm.
Okay. I'll
Yeah.
just do that.
When do we have to do that test, by?
You have to do it either tomorrow or Thursday at lunch.
This one
Okay.
was the wrong one in.
Okay.
So if somebody comes in on, oh, are you gonna be watching the test on Wednesday? So if I come in for help tomorrow, I can't have them social media.
He wrote the
It's
test.
alright.
Okay.
He wrote the test, he posted the
So,
test.
we're going to do a vertical asymptote corresponds to a non-permissible value in the equation, which is found when the denominator is set equal to 0. So all we have to do is we literally have to find out the denominator and then set it equal to 0 and find out what x value would cause your denominator to be to 0. And if you find that out, then you would get your vertical asymptote. It is the non-permissible value of the rational. If the denominator cancels after the rational is simplified, it is not a vertical asymptote. That's what we're going to deal with today. So if, ooh, great. So if the denominator cancels, which is what we're going to deal with today. So say we have an x plus 2 in the numerator and x plus 2 in the denominator, and they cancel off, then it's not a vertical asymptote. It's going to end up being a point of discontinuity, which we're going to talk about today. Now, the horizontal asymptote rules we'll deal with in a second. What we're going to do first is we're going to go to here, and we're going to find all of the vertical asymptotes. Okay? So the vertical asymptotes come from the denominator. So here, this one is 2x minus 1. So all I would do is I would go 2x minus 1 can't equal 0. And then x, I guess, would be equal to 0 because it's an asymptote. 2x, oh, dang it. No, what is going on? Ah.
Where are the notes?
It's the May 25th notes.
Oh, there it
Note
is.
to
Zippy, the lippy. Okay, 2x minus 1 equals 0. When I add the 1 over and divide by 2, I'm going to get x equals a half. So it just comes from my denominator. Because nothing in the top and the bottom cancel. The next one is in transform form. So is this one. What would be actually at the back of this one? It's in transform form because there's no variable up here. It would just be a plus 0 at the back, right? So when there's no variable in the numerator, it's in transformed form. You can just add a 0 to the back. This one's in transformed form as well because it has a basic x in the denominator, x to the 1, and it doesn't have an x in the top. So I take my x minus 4, set it equal to 0, and I move my 4 over, so I get x equals 4. The third one we didn't really deal with, so I wanted to bring it up today. I have a 4 in the top, and then I have some sort of factoring in the bottom. So I'm going to factor that off first. So I'm going to go over here and do my factor. 2x squared minus 5x minus 3. So I'm going to get 2x squared. Multiplies to give me negative 6 and adds to give me 5. Negative 6x plus 1x minus 3. Then I'm going to group. I'm going to take a 2x out, and I'm left with x minus 3. Then I take out a plus 1, and I'm left with x minus 3. So I get 2x plus 1 and x minus 3. So that's technically my denominator. So this is the same as y equals 4 over 2x plus 1 and x minus 3. Now, do either of those cancel off in the numerator? Do either of those, is there either of those in the numerator? Nope. So I'm going to end up actually getting 2 vertical asymptotes. That's all that's going to happen. You're going to get 2 vertical asymptotes instead. So I have to set both of them equal to 0. So I get 2x plus 1 equals 0, and then x minus 3 equals 0. When I solve 2x minus 1, I subtract the 1 and divide by 2. So I'm going to get x equals negative a half. And then this one I'm going to add the 3 over, so I'm going to get x equals 3. So there's actually 2 vertical asymptotes in this one. So if your denominator doesn't completely cancel off with anything in the numerator, you could end up with 2 vertical asymptotes. Yeah?
So when you say cancel, for the x minus 3 to cancel, it'd be x plus 3 on top?
No, x minus 3. They have to match exactly, and then they could cross off.
Oh, okay.
Yep. Now this one, it's not in transformed form because I have an x and an x. Goes with different rules, but that doesn't matter. Use a different color. So here I'm going to go, still take my denominator. Whoa, that is a large marker. Okay, so I'm going to get negative 2x plus 3, or back to blue, but whatever, equals 0. I'm going to subtract the 3 and then divide by negative 2. So I'm going to actually get negative divided by negative, so I'm going to get 3 over 2. And then the last one is the numerator and the denominator the same degree again, but nothing cancels off. So I just take my denominator, 4x plus 3, set it equal to 0 and solve. So I'm going to subtract my 3, divide by 4, and I get x equals negative 3 over 4.
So when do we do the canceling thing?
In the next part. We haven't done that yet.
Is that points of discontinuity?
Yep.
Okay.
So the domain is really easy once you have these. It's just x such that x cannot equal them. 1/2 xer. This one's going to be x such that x cannot equal 4 xer. This one's going to be x such that x cannot equal negative 1/2 and 3 xer. This one's going to be x such that x cannot equal 3/2 negative 3/4 XCR. Now remember, the horizontal asymptotes follow rules, right? And they're above. Draw our attention to these. So the horizontal asymptote corresponds to the horizontal line, the y value that does not exist. Now these are the rules. If your numerator is a lesser degree than your denominator, it's always y equals 0. Okay? Unless it's in transformed form, then it's y equals whatever your d value is. So if it's in transformed form, it's y equals d. If the numerator, if it's one full fraction and the numerator is smaller than the denominator, it's y equals 0. Remember, if they're the same,
It's smaller or smaller degree?
smaller degree, yeah,
So if it's the power of 1 and the denominator is the power of 2.
be 0.
Okay.
Yeah. Now here, n equals d. Remember? Yeah.
Is it possible to get magnifying contacts?
No.
Yes, that's not true.
Well, bifocal ones?
No, like
Not
ones,
contacts.
say 2 times,
No.
so I can see the board better.
For $300, you can get an eye implant in Toronto, and it will enhance your sight.
In Toronto.
Yes,
Yeah,
in
I'm not
Toronto, a Canadian
getting
company
eye
invented a
implant.
biotech that allows you to zoom in now.
So you have n equals d when the numerator equals the denominator. You take the leading coefficients in front of the variables that are the same. And then if your numerator is greater than your denominator, you often have no horizontal asymptote because you have a point of discontinuity, which we haven't dealt with the numerator greater than the denominator yet. So let's go through these ones. This is in transformed form, or if I cover up the 0, it's just numerator smaller than denominator, right? This one would be x to the 0. Like if I take this transformed form off, and it's a full fraction over a full number over a full other number, this would be x to the 0. So this would be degree 0, this would be degree 1. So my numerator is smaller than my denominator. My horizontal asymptote is going to be y equals 0. So when your numerator degree is smaller than your denominator degree, it's y equals 0. The second one is in transformed form. So what is my d actually in this case? Negative 6. So this one is just going to be y equals negative 6. It's just whatever the heck the d value is. The next one is degree 0 in the numerator and degree 2 in the denominator. So my numerator is smaller than my denominator, so it's at y equals 0 every single time. And these ones are the same degree. Degree 1 over degree 1. So I just take a fraction of their coefficients. So it's going to be y equals 3 over negative 2. And then this one's degree 1 and degree 1, so I take a fraction of their coefficients. So it's negative 5 over 4. Not anything with the 2 and the 3. Even if I have it out of order, you take the coefficients, leading coefficients, the ones in front of the x to the 1. So it's going to be y equals negative 5 over 4. And then my range is just can't equal those.
Do you change the order around just to mess with us?
Yep.
Great.
This one's not equal to 0. This one's y such that y cannot equal negative 6.
Why couldn't you put the y-e-r all the time?
Because it's important.
Otherwise, it would be an integer.
And then it wouldn't be connected. And you just have dots on a graph.
But then it should be like a full graph instead of the asymptotes, because it just equal everything, right?
No, if it was integers, it would just have dots at like
I mean,
x
if you,
equals
if
1,
you don't
y
put
equals
y-e-r, then it just implies it could be anything, so you get kind of a full.
It doesn't imply anything, actually. It would make you lose marks. You have to follow behind what it is.
Thank you, Marshall.
Because then you're just assuming.
No.
So,
You're
points of discontinuity. What the heck is that? Point of discontinuity is a coordinate on the graph of a function that is not continuous. So there's a hole in the graph. So you have a graph, and within that graph you have an open dot, a hole that doesn't exist. It occurs when the numerator and denominator of the rational function are simplified By dividing out the common factor. So if you have a common factor that divides out, you have a point of discontinuity. The missing single point is represented by an open circle in the graph, and it's considered to be a hole in the graph. Now, majority of your calculators, you'll see that there's a hole in the graph if you look at the table of values. If you literally just look at your graph, if you just press graph, you can't see the open dot. If you have the TI-83s, you're for sure not seeing it because it wants everything to be continuous, just like it connected your rational graph. Remember I told you there's an asymptote in there, but it tries to connect it? It'll connect the open dot as well. If you have the new ones and you zoom in close enough, some of them you can see like a dashed open space. The majority of the time it doesn't, you can just see it in your table of values. So we're going to consider this function here, and you're going to pay attention to it so that we can see an example of it. So we have the function f of x equals x squared minus 5x plus 6 over x minus 3. Now my numerator is actually a larger degree than my denominator. We haven't had that yet. So my numerator is degree 2. My denominator is degree 1. Do you see that? So our numerator is actually bigger than our denominator. Well, the first thing we have to do is actually factor the numerator. When I factor the numerator, I get x minus 2, x minus 3 over x minus 3. Then what happens to these two? They just cancel, correct? The moment you can do this, you have a point of discontinuity.
Why are we just learning about this then?
Because this is the lesson, 4 points of discontinuity.
But we've had to cross out things like this in the past.
No. All right. So we don't know. So when we cross that out, we get x minus 3. So x equals 3 is the answer to that, right? We've done it the whole time. However,
Is that a 2? 2's left over.
so our non-permissible value is x minus 3 at the bottom. When we cross that off, we get x equals 3. Now that's going to be our x value for point of discontinuity. Now normally, if we have our denominator here, we just solve for it and it's our vertical asymptote. We agree? Yeah? But if it crosses off, it's not a vertical asymptote, it's a point of discontinuity. It's an open dot. That's the difference. So we still solve for it the exact same, it just happens to not be a vertical asymptote. It's not a dashed line, it's going to be an open dot. Well, it's an open dot at 3 and something, because it's a point of discontinuity. People will tell me, it happens at x equals 3, that's great, but it's a point of discontinuity. A point of discontinuity means it has an x and it has a y that doesn't exist. Now, how do you get the y? Well, this is the thing here. Once those cancel off, we're left with this equation. F of x equals x minus 2. So that's the actual graph that's going to get drawn. So we go over here and we draw the line x minus 2. So we start at negative 2, we go up 1 over 1, up 1 over 1, up 1 over 1, and we would draw our little line. It would be just like this. And most people will draw the line and stop. The problem is, yes, that is the graph of this, because once I cancel it off, whatever cancels off, you draw this. But you have to also make sure you put in the open dot. Well, where the heck is it at? So, which marks the linear graph with a hole at x equals 3 and a y value we need to solve for. To determine the point of discontinuity, substitute x equals 3 into the simplified equation. So you take the simplified equation and you find the y value that goes with it. If you put it into the original, it's not going to work. If I plug 3 into here, I'm going to get 0 over 0. It's going to be 0 every time, and you're going to get, it's not right. So you always plug what x value you get into the simplified equation. So I do f of 3 equals, and I plug it in. 3 minus 2. 3 minus 2 is 1. So my point of discontinuity is actually at 3 and 1. So I go back in here, and instead of drawing the whole line at 3 and 1, I have an open dot. And then I have the graph going the rest of the way. But you have an open dot at 3 and 1, which is the point of discontinuity. Okay? So this was all done for you. Now we're going to go over to here. So, steps to determine coordinates of point of discontinuity. Where will points of discontinuity happen? Points of discontinuity can happen when your numerator is greater than your denominator, or your numerator and denominator are equal, but they're both degree 2. They both have to be degree 2. If they're both degree 1, we get a vertical, we get a horizontal asymptote, we're done. If they're both degree 2, you could factor them and stuff could cancel. Okay? So when we see a degree 2, the very first thing we're going to have to do is factor it. So I'm going to do this up here. I'm going to go y equals, now what can I do to the numerator? I can take out a x. And then I'm left with x plus 5 in brackets. And I can put the x in its own brackets because it's multiplied. The denominator is x squared plus 7x plus 10. So what multiplies to give me 10 and adds to give me 7? X plus 2 and x plus 5. What's going to happen here? Yes, those x plus 5s are going to cancel. So I know I immediately have a point of discontinuity. Last time I solved this, though, in the last example, the whole numerator went away. Or the whole denominator, sorry, went away. Did it this time? No. So the graph I'm actually left with for this one is y equals x over x plus 2. So that's the graph I'm going to draw. And then it's going to have an open dot somewhere. It's going to have an open dot at, what does this get me? Negative 5. And how do I get my y? Plug it into here, right? So I get y equals, and I plug in negative 5. Negative 5 over negative 5 plus 2, which actually gets me negative 5 over negative 3, or 5 over 3. So there's my point of discontinuity. Negative 5 and 5 over 3. This is the graph that I'm left with. This one here. Now, if we just did that one, which we just did in the previous table, what did that graph give me? When the degree of the numerator and the degree of the denominator are the same and nothing cancels off, I have a vertical and a horizontal asymptote. Right? So, in the last one it canceled off and all I had was a line. But when this one cancels off, I'm actually left with a rational. So what is my vertical asymptote of this leftover graph? Yeah, because we go x plus 2 equals 0. So we get x equals negative 2. And what's my horizontal asymptote? They're the same degree. So this is degree 1 and degree 1. So it's going to be 1 over 1. So it's going to be at y equals 1. I'm not concerned about the x and y intercepts. We'll ignore those for now. Do you understand how I got those things, though? How I got those? Okay, this is where people mess up. So people will fill that incorrectly and then mess up the domain and range. My domain R is where my x's don't exist. So people will say x can't equal negative 2 xer, which is true, but there's more that don't exist. This also is an x and a y that don't exist, right? It's an open dot. So my domain is going to be x such that x cannot equal my vertical asymptote, which is negative 2, and my x is my point of discontinuity, which is negative 5 xer. Okay? Now my range, and most people forget the points discontinuity part. My range is going to be y such that y cannot equal 1, and then the y of my point of discontinuity, which is 5/3 yer. You guys are going to try this one out. So we're doing B, the work down here, factor it. C, work down here, factor it. All right. So for this one, we factor the top, what multiplies to give us 12 and adds to give us 7. It's going to be x minus 5, x minus 2, nope, x minus 4, x minus 3, I don't want. X minus 4, x minus 3. And then x squared minus 9, I get x plus 3, x minus 3. And then immediately, when I see these cancel, I know I have a point of discontinuity at 3, because it's x minus 3, so it's going to be 3 and something, right? Now let's go down here for a second. We have the equation y equals x minus 4 and x plus 3. How do I, this is the equation that's left over, right? I'm going to get the y, I'm going to come back to that in a second. I'm going to get the y of the point of discontinuity by plugging in x equals 3 to get my y into the simplified. So I get y equals 3 minus 4 over 3 plus 3. So it equals negative 1 over 6. So this is negative 1 over 6. I just plug my x of my point of discontinuity into the simplified equation, right? On a diploma, that's actually a standard of excellence question. It's the easiest standard of excellence question on any diploma I have ever seen. So I always say, if you get that, that should be like your give me standard of excellence. Okay? Now,
The standard.
standard of excellence is like 20% of your test needs to be standard of excellence, which are the harder questions.
Why?
If I ask you for the x value of the point of discontinuity, it's just a normal question. And it's called just a normal, your normal standard question.
They're below that.
Yeah, there's standard of excellence, which is 20 to 25% of your test, and then the rest is just your normal standard.
Well, I'm glad I'm not taking the diploma.
Isn't there like standard of like 4?
Yeah, it's called failing.
Yeah,
Okay.
just don't do it.
You
So-
gotta have some easy questions on it too.
All of them are easy.
So when we go back to this is my simplified form. When I'm in my simplified form, then I state my asymptotes. If there's still a denominator, I have a vertical asymptote, right? If there is no denominator, if all I have is a line, I have no asymptotes. None. I'm just done. It's really easy. So if I'm still left with a rational graph, I base it off my denominator. So I have x plus 3 can't equal 0 for my vertical, or equals to 0, sorry. So x equals negative 3. For my horizontal asymptote, I look, these are both degree 1. So once again, I take their leading coefficients, which is 1 over 1. So it's going to be at y equals 1. And then my domain and range are based off of my asymptotes and my points of discontinuity. So this one's going to be x such that x cannot equal negative 3 from my asymptote, and 3, so plus or minus 3, I can write them together, from my point of discontinuity, xer. If you didn't write them this together and you put a comma in between, totally fine. Don't freak out. And then my range is going to be y such that y cannot equal 1 from my horizontal asymptote, and negative 1/6 from my point of discontinuity, since where there's a gap, y here. Now the last one is actually nicer. So if I go to factor that, off to the side I'm going to factor 2x squared plus 5x minus 3, it's decomp. Multiply is going to be negative 3, and or negative 6, sorry, and that's going to be 5. It's going to be 2x squared plus 6x minus 1x minus 3. Take out a 2x, I'm left with x plus 3. Take out a negative 1, I'm left with x plus 3. So I'm going to get 2x minus 1 and x plus 3 in my numerator. My denominator is x plus 3. So the x plus 3's are going to cancel. The moment they cancel, that's no longer a vertical asymptote. That is the x of my point of discontinuity, right? What value would it be? Negative 3. Now, what's my simplified equation? Well, it's just going to be y equals 2x minus 1, which is a line. Does that give me any asymptotes? No. When it actually cancels into just a line, you should like throw a little party, because there's no vertical or horizontal asymptotes. It's just a line. Do you see how these ones reduced to, this reduced to a rational here? And this reduced to a rational up here? So they ended up with asymptotes, correct? But when it completely cancels off and all I'm left with is a line, all I have is a point of discontinuity. Now I have an x, how do I get my y? Well, once I box my simplified equation, I just plug it into there. So I have x equals negative 3, and I need to plug it in. So I'm going to get y equals 2 times negative 3 minus 1, which is negative 6 minus 1, which is negative 7. So all I have is a line at 2x minus 1 with an open dot at negative 3 and negative 7.
I'm confused that x equals negative 3.
Because it's negative 3 would make my denominator be 0.
Oh, that's like that.
Right? It has to be the non-permissible value,
Okay.
because it's where the graph does not exist. So if I plugged a negative 3 in here, negative 3 plus 3 would get me a 0 in my denominator.
Okay, thank you.
Welcome. Now, x is my only problem is negative 3, and y my only problem is negative 7. So my domain is going to be x such that x cannot equal negative 3, xer. And my range is going to be y such that y cannot equal -7. Y here. Your homework. I know it sucks that you have homework.
Well, I already know how to do this all perfectly, so just do it.
Page 452, numbers 4 to 6. So,
How much sub questions are there left?
it goes to